Okay, in this lesson we're going to cover sections 6.6 and 6.7. Really the focus is on 6.7, which is all about the imaginary number I. Before we do that, though, we quickly just review the properties of real numbers so that you can understand how an imaginary number isn't classified as a real number. So basically what you can expect to do in this section is be able to classify numbers, which is something we reviewed at the very beginning of the year. So every real number has a decimal representation, and every decimal represents a real number. So let's take a look at the classifications. Okay, here's a pretty nice visual that shows all of the real numbers and the subsets of real numbers. So if you look in the innermost section here, we have natural numbers, which is sometimes just called counting numbers, 1, 2, 3, 4, 5, etc. Whole numbers also include the number 0. Integers go on to also include negative numbers. Rational numbers, rational has the word ratio in it. It basically means that you can write this as a fraction. So that would include the number like 7, because I could write 7 over 1. That's a fraction. It could include the number 0.25 because I could write that as a fraction, 1/4. This is also true of repeating decimals, like 0.3333 repeating is the same as saying 1/3. So either terminating decimals that we can write as a fraction or repeating decimals as well. Finally, irrational numbers, which you can see it's in its own little subset here, so it's not nested like these other sections. It's still a real number, but it's a number that you cannot write as a fraction. So that's, for example, like pi, 3.14, etc., etc. It's a non-terminating, meaning it doesn't end, and non-repeating decimal. So we're going to do some quick examples with just classifying these numbers, and then what we're going to do in 6.7 is talk about imaginary numbers, which would, if we were to draw it on this picture, not even fall within any of this circle. It's not a real number at all. So everything up at the top is just pretty much repeating what I was saying about the difference between rational and irrational numbers on the previous slide. So something you might have to do on the test or the final exam is be able to classify numbers as either rational or irrational. So looking at the first one here, square root of 2, if you were to put that in your calculator, what you'd see is you would get a non-terminating, non-repeating decimal. So that's going to be an irrational number. The square root of 4 over the square root of 9, if you remember your radical properties earlier in the chapter, we can take the square root of the numerator and denominator separately, so 2/3. If you can write it as a fraction, that's a rational number. In the next example, I see a repeating decimal. I see 0.3, 0.3, 0.3, and that's going to continue to repeat. If that's the case, this is a rational number. However, if the decimal does not repeat, so 0.3, 0.003, 0.003, so that has a pattern, but it's not a repeating pattern. You're not getting the same thing over and over like you do in the previous example. So this is going to be an irrational number. Sorry, my screen's being funny. I'll write it over here. Irrational, abbreviating. All right, now we're going to move into 6.7 where your homework problems are going to come from. So we're going to learn about what imaginary numbers are and how to use I to simplify square roots of negative numbers. I'm going to read this first little paragraph to you because I think it does a good job explaining imaginary numbers and why they're useful, and then we'll go into some examples. So it says, throughout the history of mathematics, new numbers have been invented to extend the existing number system. For example, the invention of negative numbers made it possible to solve an equation like x plus 3 equals 2. Because we know if we solve that equation, we would subtract 3 from both sides, so we'd get x equals -1. So then it says, similarly, the invention of an irrational numbers made it an equation like, and it got cut off, but I can make one up, x squared equals 2 solvable. Because we could take the square root of both sides and we'd get x equals plus or minus 2, root 2, which is an irrational number. Now look at this equation, x squared equals negative 1. Now we know this equation has no real solution. So if we tried to take the square root of both sides, we would get the square root of negative 1. At this point, you had been writing as an answer that this is not a real solution, which is true. But with the invention of imaginary numbers, we're able to solve an equation for this. Solve an equation like this. So the definition of I is literally the square root of 1, just like this example we were just doing here. So it immediately follows then, if I square both sides of that equation, or from that definition, we know the square root of negative 1 squared. Squaring a square root, you would just get negative 1. So this statement is also true. I squared equals negative 1. Having these two definitions, having this definition and then this consequence of that definition memorized is going to help you to work with imaginary numbers. Okay, so for the rest of this section, we're going to do some basic simplifying and solving of equations. And it'll be in 6-8 that we focus on adding and subtracting and multiplying and dividing. So today is all about just some simplify and solve. So the square root of negative 9. Basically, if we use our rules of radicals, first of all, we can think of this like the square root of negative 1 times the square root of 9. Where we know the square root of 9 is 3. The square root of 9 is 3, and then by definition, what we just learned is that the square root of negative 1 is I. So I times 3 is just 3I. Looking at the square root of negative 25, we can think of this as the square root of negative 1 times the square root of positive 25. Square root of 25 is 5. By definition, the square root of negative 1 is I. This next one here isn't a perfect square, but we could still think of this as negative 1 and 20, square roots of those separately. So this is going to be I times the square root of 20, but we know we can break down the square root of 20 more, because 20 is going to be 5 times 4, and 4 is a perfect square. So 4 gives us the perfect square 2, when we take the square root of 4, and we're left with 5 under the radical. So we're going to write this as 2I root 5 for our final solution. Here's another example. So if we take the square root of negative 100, we can think of that as the square root of negative 1 times the square root of positive 100, where we know the square root of positive 100 is 10, and by definition the square root of negative 1 is I. And we can do the same thing with the square root of negative 81. Think of it as negative 1 times the square root of 81. So that's going to be 9I. Now we're going to go over this more in the next section, but just to preview, we can go ahead and add imaginary numbers together. So if you have 10I and 9I, you have 19I. And then moving right along here, we have the square root of negative 5 times the square root of negative 3. So for the square root of negative 5, we have the square root of negative 1. Oop, put the negative in the wrong spot. Square root of negative 1 times the square root of 5. And then for the square root of negative 3, we can break that up as well. So we know by definition the square root of negative 1 is an imaginary number I. So we have I times root 5 times I times root 3. Well, I times I is I squared. And then root 5 times root 3 is root 15. And then we learned by definition on the first slide that I squared is the same as negative 1. So we have negative 1 root 15 or negative root 15. Example 6, we have the quantity I root 11 being squared. So remember, this means we have I root 11 times I root 11. So I times I is I squared, and root 11 times root 11 is just 11. We learned that by definition, I squared is negative 1. So we have negative 1 times 11, or negative 11. Finally, square root of 6 times the square root of negative 6. We have the square root of 6. And if I think about this as an imaginary number here, I can break it up into square root of negative 1 times the square root of 6. We know square root of negative 1 by definition is I. And then root 6 times root 6 is root 36. So we're just left with 6I. Okay, here's a rule. So just like we did with radicals all throughout this chapter, we can't leave radicals in the denominator. Same thing with imaginary numbers. So let's go ahead and get this I out of the denominator. The way that we do that is we multiply by I, because we know I times I will be I squared, which is just negative 1. So that's a real number. Now you can't just multiply the denominator by I because that changes the problem. So you're going to have to multiply the numerator as well, so that all you're really doing is multiplying by 1. So in the numerator we're going to get 4I, and then we know 4 divided by negative 1 is just negative 4I. So same idea here. This is 10 over, and if I go ahead and write this as an imaginary number, so it's the square root of negative 1 times the square root of 2. So that's I root 2. So we need to go ahead and get the radical and the imaginary I out of the denominator. So to get I out of the denominator, I need I. To get root 2 out of the denominator, I need root 2. Whatever you do to the numerator, or denominator, you have to do to the numerator. So when I multiply straight across here, I'm just going to get 10I root 2. And then when I multiply the denominators, I times I is I squared. And root 2 times root 2 is just 2. So in the denominator, what I really have is just negative 2, because I squared is negative 1. Finally, I can reduce 10 and negative 2 and just get negative 5I root 2. Okay, the last thing we're going to do is just solve a couple equations that would have imaginary solutions. So if we want to solve for x in this equation, and I have x squared, I'm going to need to take the square root of both sides. So I get x equals plus or minus the square root of negative 289. Now, based on all the simplification rules we've been practicing today, we can go ahead and write this as an imaginary solution, because square root of negative 1 is I, and then the square root of 289 is 17. So x is positive or negative 17I. Alright, let's try the same thing with number 11 here. So we have 3n squared plus 15 is 0. If I isolate n squared here, I'm going to subtract 15 from both sides. So I get 3n squared equals negative 15. Dividing by 3 gives us n squared is negative 5. So we know we're going to have an imaginary solution because I'm going to take the square root of a negative. And the square root of negative 5 is I root 5. Alrighty, that's it for today. Go ahead and check Schoology for homework.